Hello there, my name's Vince from My Mate Vince, and in this video today we're going to be trying to fix up this treadmill here. So it's a Reebok one, and I'm around Brian's house and his son uses it. Now it's normally in this gazebo thing here, which is actually waterproof. I've pulled it out just to have a little bit more light to make it a bit easier for filming. Now Brian has said that he's already checked the fuse here and that's okay, but it's totally dead. So it was working, and then one day came out and it wasn't working. Now it is turned on right now, and when you actually, I should maybe stand off it, when you hit this button here, it's supposed to come alive, but there's nothing happening at all. If I hold it down, there's nothing happening. I've tried putting this off and putting it back on just in case it was dirty or something, and it's still not doing anything. So it seems like it's completely dead. So I have to make a decision. Do I want to start down here where the power comes in, or do I want to go up here? For example, maybe this on and off button is not working. I'm thinking I might initially have a look down here. Also, I'm just going to double check the fuse, and also maybe we should see if we can get access to this switch. So yeah, let's check the lead to begin with, then the fuse, and then maybe we should try the switch next and take it from there. Now, in case you haven't seen my videos before, I've never worked on a treadmill. I like to try to mix up different items, so I'm an expert in absolutely nothing. But let's just see if normal fault finding with a little bit of logic can get this up and running again. First things first, we're unplugging it from here. It's not normally plugged in to this one here. I've just dragged it across there purely for the video. And let's get the other part of the lead, and we'll do a continuity test. So, meter sets continuity, beeps. Let's see if we have everything here. So, earth, yes, live, yes, and neutral. So 100% that cable is okay. Now let's check that little fuse. So I'm just using the little Phillips. And we have a fuse here, and the fuse is okay, so hopefully you can hear that beeping. Right, I think we need to try to get to that switch next, just purely to follow the path in, but I'm not sure how you get to that. Let me have a little look around the machine and see if there's any obvious screws that I can undo, because I need to like lift this up. I can see there's a screw here, here and down the bottom, and it does look like that's holding on this plastic thing. I presume there's going to be another screw under here and here as well, and 3 that side. The problem is I haven't got access to them, because I can get to this one, but I can't get to this one because all this is in the way. So I'm wondering, do I have to, because I can see that there's a cable there. So that's going to be sending the signals from the bottom up to the top. Unless, of course, that cable has somehow come undone from the top, because that's going to be travelling up this arm here. I mean, this is left outside, but it's undercover here, but unless condensation or something has gone in. So I'm wondering, would it be maybe easier to undo these ones here to take this off, just to see? I'm not sure. I mean, I would like to see what's going on in here, because I want to test that switch. I'm just not sure how easy that's going to be. So it might be easier to do this here. Well, I didn't want to start here, but I think it's the easiest thing to do. You never know, it could be just a corroded or a loose connector. Ah, so looking at it, I was expecting this to drop down. I don't think it does. I think the idea is you undo them and then the front panel comes off. Oh. So
oh yeah, oh you're right. Oh yeah. It doesn't look like any dampness there, does it?
No. Well, let me just get the camera up here, Brian.
Okay.
I'll just say it now, obviously don't copy what you see in this video. It's a treadmill. It's going to have moving parts when it's working, but also there's a serious amount of weight to it, and if I was to undo the wrong bolt or something, this might drop down and it could chop off your hand or finger or something like that. So take this video purely for entertainment. I do not know what I am doing. Right, so as you can see here, this is now off. I'm just having a little look around the place, see if there's anything that's come loose. But these all look like they're hot snotted in. So I don't think that is, don't think the issue is going to be here. I can't see anything that looks loose. And we have two cables coming up. That one there and that one there. And I presume they are the ones going down to the bottom. So maybe these two here are the actual main feeds up here. Looks like there's a little reset button there. I'm trying to see, is there anything on the board where I can test, test for voltages to see if there's even voltage getting up here. And we have another two buttons here as well. Right, this one does say SW power signal. Would that be switch power signal? On that ribbon cable. And that goes around. And yeah, that is one of these. But also we have ones going down here as well. Oh, that might be to do with we have like incline and a heart rate monitor thing. That all looks perfect. That's nice bright silver. And that one, there's definitely there's zero corrosion there. In my opinion, everything looks immaculate in there. There's no signs of water damage, dampness or anything. Ideally, I still want to be testing the switch down below. I might be able to kind of pry it out from the outside. Might look into that. Or I suppose the next thing to test is that working? Now, I don't know if this is going to be on a membrane, but it definitely sounds clicky. So there might well be a physical button. So I suppose we could test that. Also, this one here, I can hear it clicking. I'm not saying it's working, but it's clicking. And when I put this down, I can hear it click. There. So that's definitely clicking. It's not like fouling with dirt or anything like that. I'm going to undo some screws underneath and see if there's a way that maybe, I'm not sure, maybe then this part here can pop out. Because maybe it's as simple as the start button here is not doing what it needs to do. So it looks like we have a load more screws around the edge here. So I'll undo them and see if the top pops off. Right, I've got one more screw to undo underneath and hopefully it will release it. Ta-da! Right, now how are you going to come out? I wonder, have I missed the screw? It seems to be held in here. Yes, I have. Gotcha. Right. We have it here. So, have we got, yes, we got clickable buttons. This is good news. In fact, we don't need to undo it because I've got the contacts at the back. So if I get my multimeter on continuity and press that, we should hear it going off here. Right, so it is this one here. So if I go on Diagnose and press it, let's see what it's going to do. That switch is working. I think because again, there's no corrosion here. I think that all looks all right. I think, annoyingly, we are going to have to get to the bottom, the switch at the bottom, and test that. So I think we're going to have to get a socket set out and start dismantling the actual machine itself. Right, so these are the 3 screws I want to get to, but we do have, it's like on a metal bracket, we do have a screw here and a screw here, so maybe if we undo the metal bracket, we then don't have to worry about undoing those ones. So we're going to undo those 2 here, and then see what's happening, and then maybe flip it on its other side to undo the other 2, and then we're not sure what's happening here, but either way, we want access in there. Right, so Brian's just undoing this screw here, and there's this one here as well. We will have to lift this down a bit. You've got to be so careful, because obviously when we put it on its side, this here swings down this way, because I presume the strut there is to allow the treadmill to fall nicely, but when it's like this, I think the strut can open up no problem at all. So if you were to have your hand or body or leg caught in there, I think the weight of that could do some serious damage. But like I say, don't copy what you see in the video. So we've undone that one. We need to now undo this one here, so we're going to have to probably move the treadmill a little bit.
Oh, I've got to push this down.
Oh yeah, on the red. Red.
Okay. Sorry, Vince, I know you're strong.
Is it okay?
That's
Is it
probably
going?
Enough.
Yeah. Well done. Right, let that go again. There we go. Right, hopefully now this. Oh, there we go. Yes, we are in. We're in. Brilliant. Oh, that's fantastic. Right, now this is more like it. This is more like it. Okay, well, first things first, I'm going to get the camera on a tripod. We're going to test this switch here and then follow it through from there. There's all sorts of stuff going on here that I do not have a clue. What is that there? An EM filter. So here we have the switch. Let's see what it is doing. So this should now be on, and I'm on continuity. Right, so we have it there. Turn it off. We haven't got it there. That's correct. So that's on the neutral, and they've also switched the live as well. So it's switched on. It's switched on both. Oh, hold on. Ah, no, we got it. And off. Right, definitely not the switch. Where do you go from there? So from here, it looks like it might go into the fuse, which we know the fuse is okay. We have a spade connector there. I think that's all right. And then it must go up here into this thing here, which I'm not sure what it is. This thing. Also, I've got to be careful because it has been plugged in, so there might well be voltage left in certain things. Just having a quick look around, see if there's any loose connections. But that's definitely the next path here. So it goes in here on the left hand side and comes out on the right hand side. I'm going to take a quick picture of that and let's see what ChatGPT says it is, because I'm not sure. Is it some like massive startup type capacitor thing, or I really don't know what that is. And just in case that spade connector isn't doing what it's going to do, let me go onto the black one and onto black here. So that's okay. So it's going from the switch to there. And let's just go onto the live, and that way then we know that spade terminal is okay. Yeah. So the wires themselves are okay. I took a picture and googled it, and it is, funnily enough, as it says, an EMI filter, so for electromagnetic noise. It actually says for treadmills. And so I thought to myself, well, clearly then it must be just like continuity through it. And if you have a listen here, if I go onto the black one and this bottom red one, my meter is beeping. You may or may not hear that. And if I go on to the live one here and this top red one, again, it's beeping there. So we should have voltage going into this board. Now it could well be a problem with the board. I presume this board's going to have a fuse and stuff on it that we can test. I can see a load of capacitors here. So I might have to take that out to fault find. But what I'm thinking is the cable that feeds the top board, because remember we've got nothing on the top board, goes through this thing here. And there is a possibility, unlikely, but there is a possibility that it could be damaged where it's going through here. You know, maybe it's been snagged and pulled. So I think the next easiest thing to do is take off the hot glue from here, because I can see that this is the one that goes through and then up the arm. And then let's get a continuity test, and that way then we've proved the cable's okay from here up to the control board where you press the buttons. Right, so we're now at the top half here, so if I undo it from here, then we can test down at the bottom. Now there is two going through here, but one of them again is going to be for this like heart rate sensor and speed control thing here. So I presume the green one says that was the one. Was it this one? No, it was this big one here. It says switch power signal. So it's this big fat one, which is this one. So I think we just undo it from here. Don't want to overstretch any of the wires. And let's see if we have continuity between these points here and the points at the bottom. Well, hopefully my leads are going to stretch. Right, we have that one. I know you can just see the back of my back. And we have that one. We have that one. This is not looking good. We have that one. And lastly, I'll try to get out of the way of the camera. We have there. So we've got them all. So it's definitely not that. So if there's no life coming up there, I think there's a very good chance that it's this board here that is faulty. I mean, if I was to get rid of all the hot snot glue, it might well say on the board what the different pins are. And I might be able to measure, for example, if there was 5 volts here, then I know we're going to have 5 volts up there, because it could be a problem with the top board, the display or something. But it just all seems dead, so I think it's going to be a problem here, because this looks like the main power board. And then we have the motor here, plus and minus. The motor's labelled up as DC. And when you turn this here, you can see that the treadmill's starting to turn. And look at this, we have little holes here. So that must be like a speed sensor. So it knows how fast this is rotating because of the holes, and it's measuring from one side to another. Very similar, that reminds me of the hoverboard that I fixed ages ago. Had something very similar, and it knew when you were, you know, going like forward and backwards and left and right. Now, massive bearings up here as well on the roller, huge bearings. There's that there. I think we're going to have to take this board out, or first of all I'm going to try to get rid of the glue from here, and just to see if the board's marked up, because this is where the connector is, so we should really have like 3.3 volts or something on that connector. Well, I took the hot snot glue off, and there's nothing, annoyingly, there's nothing labelled up on the board there. I think we have to take this board out. So I've got to undo everything else. It's not actually too many things. Most of these are just spade terminals, and these ones here have glue on. So I'm just going to take the glue off. Brian has got some IPA, so when he gets back, if I haven't managed to undo these, I can get some IPA off him. But this seems to be coming undone okay. And then we have 2 massive screws here and here to take off this whole block. It's like a aluminium heat sink, and it looks like we have components there that are on that spreader at the back with a load of thermal paste, so possibly they might have gone if they're sensitive to heat. Now that's interesting, they've put this on. This isn't idiot proof. This is on the right hand side, so I'm going to take a picture of that, because there'd be a chance you could put it on the left hand side. Good news is you might well be able to buy these boards here, and if the fault is on this board, and let's say if I can't fix it, then if you could replace the board, at least you've still got the whole treadmill that's going to work. It'd be a shame to throw away the whole thing for the sake of this one board here. So okay, that's out now. What is interesting is we have this here which looks like a transformer, but there's only 2 wires going to it. There's no wires coming out of it, so what on earth is it doing? Do you know what I mean? We have a red and a black going into it. There's nothing coming out of it. And it does say AC 115/250 volts AC 6 amps. It looks just like a transformer, but I can't see any wires that come out of that. So even if it was for another model, well, you can't plug anything into it. So I don't really know what's going in there, unless it's using the black and the red. You know what I mean? Unless it's like red in and black out or something, but what's it doing? Right, what we got? So the red one from the EMI filter goes into the board. The red one from this other red one from the EMI filter goes into the transformer, and that comes out. And this is something to do with noise. I don't know, I can't get my head around that. As far as I can see, transformers normally have 2 wires in with a coil, and then 2 wires out on another coil, and it induces across that, unless of course it's not a transformer. Right, okay, let's this motor here is going to be to the raising up and down, and this is to do with the treadmill. I think the fault is going to be on this board somewhere, so let's start fault finding this and see what happens. It does look like we have a fuse, so shall we start on the fuse here? Let's do a little bit just on the ground. I might have to take this back to the infamous blue mat. Right, continuity. Let's go underneath. Fuse is okay, it's not the fuse. Can I see anything dodgy looking? Weirdly, when I disconnected the wires, I thought I heard a click, and I thought, could that be a relay? We have a massive capacitor here and a noisy bird. This is 450 volt. Ideally, I want to test that. I wonder, can I get in here? Let's go to DC. Let's see if I can't get in here. No. How do I take this board out? I've got to undo these 2 at the back, haven't I? So we have, what would that be, a bridge rectifier here? I bet that's a bridge rectifier. And then 2 massive sort of like switching transistor type things. See, I don't think it's as easy as just plugging in the AC and seeing if it works, because then we're going to have something else which goes to the motor. This goes up, this might only come alive when it gets to signal here to turn on. It's a really hard one to fault find. Do you know what I might do rather than take out the board, because it's going to have all the thermal paste and stuff on it. I mean, there definitely is evidence of some kind of animals here, but it's not bad. I'm wondering if I should connect it back up but leave lots disconnected. For example, why don't I disconnect the motor here, and why don't I disconnect the motor here and see what happens, and then maybe on the top board I can disconnect stuff. But there might be some fault on the top board. There might be a short that's knocking everything out. Do you know what I mean? So it seems pointless in having to fault find this when we haven't even proved if it is or isn't this. So I'm going to put this back in. Right, so I've just temporarily put this back on, and I haven't connected anything apart from the cable that goes up to the top board via this big arm here, and also the mains coming in. You can see the red and black wire there. So I've disconnected the 3 from here. That's these 3. They're feeding this they're feeding this motor here that goes up and down. I've disconnected these because all these are little sensors for the speed, and sensors again so it knows what angle it's at. And I've also disconnected these 2 which go down to feed the DC motor. So all we've got now is the board connected here, and we know the switch and stuff is okay. I believe the filter's okay because we've got power going through it, and we know the fuse is okay there. And then it's just going to be going straight up into here. And so what I'll do is I'll turn it on now. I'll probably get Brian to help me lift it back up just in case it suddenly goes crazy, and we'll see if it's working. If it's working, maybe this is knocking it out, or maybe this is knocking it out. Let's say if it's not working, then what I'll do is disconnect all the connectors from the top board apart from this one, and then see if we have some sort of display. There might be something on the touch panel board which is putting a short on, or there might be some other sensor on the arm which is putting some weird short on, which is knocking it out. So I think that would be good, because maybe we can do some elimination. We've got it back upright. Obviously I'm being super careful now, because when I turn this on, this is all going to be live. I've tried to tuck all those dead wires out of the way because I don't want anything touching the actual metal itself, and making anything live that shouldn't be live. So let's turn it on. I'll just do it with my foot, and because I'm just thinking about the way it clicked. And let's now hit start and see what happens. So there's still nothing there. I'm just going to stand on it just in case it recognises that there's weight on it. I don't think it does. I thought I heard a relay click there. Hold on. Let me stop it. I don't know if I'm hearing things or not. I'm just going to turn this off. I've heard a relay click a couple of times now. Right, let's just try to drain the power. Oh,
no, that's mine.
Is that your phone? I thought it was a bing off coming alive.
I was going to do something to
You got my you got my hopes up.
Stood on it, I was going to...
Right, on now. Let's listen out for a relay click.
Sorry.
That's weird.
I'll turn it off while you're on it.
No, don't worry. I didn't hear any click when I think I'm hearing clicking. Was it me standing on and off this? Well, anyway, look, there's nothing happening here. So what I'm going to do now is I'm going to kill power, and now I'm going to take this out again because it's only held in with a couple of screws. I'm going to start disconnecting other things to see if anything comes alive. Right, so this board's out now. I can definitely see it says safe key just here. So that must be the one that goes down to this lanyard thing. Now, if the lanyard thing's not connected, maybe it won't come alive at all. So I'm going to get some isopropyl alcohol, and I'm going to get rid of the hot snot from here. I'll probably do it from everywhere actually, because the idea is I want to be disconnecting stuff to see if something suddenly comes alive. But at least then we can test this. So when the safe key's not on, I presume it's going to be open, and when the safe key's on, then I presume we should have continuity across these two wires. So I'm just going to use isopropyl alcohol to help remove the glue. Right, only undone one, which is the safe key, because we might not need to undo anything else. So let's see now if when we go in here and here. Right, and now lift it off. So the safe key's working. We're no closer. We've eliminated some stuff, but no closer really to find out what the problem is. So we're going to take off all the other glue now, and then yeah, I'm just going to, I suppose, disconnect the speakers, disconnect other things, and see maybe if it will come alive. Right, Brian's taken off all the glue there with the isopropyl alcohol, and it just lifts off real nice. So I think now we've got the minimum connected to possibly make it work. So from the board at the bottom, it comes up on this one here. This is for the little safety switch here, and then we have this going down to the front board to be able to turn it on, and this board is powered purely from this one here, from what I can see. So oh, we've got an aerial as well. Okay, well the aerial's still connected because that's soldered on, but that's not going to stop it from working. So I think that's the minimum we need. So now we're just going to put the screen the other way, and I'm going to plug it in again. Let's see if we've got anything now. Right, keep my hands well clear from everything again. So plugging it in here. Obviously this is more dangerous because it's been done outside. Plugging it in here. Oh my word, do you know what we haven't tested? Oh no, this would be really embarrassing. We haven't actually tested to see whether or not this works. Oh no. Oh, imagine. Oh, that would be embarrassing. Oh no, I think it might be that. Right, anyway, listen, let's just do this. Just let's hope it's still, fingers crossed, a 40 capacitor. Oh, I'd be quite embarrassed if it was that. I've cleaned up the screen as well. Right, let's see. Nothing. You know what? I'm thinking now it could be electric. Let me get a lamp or something. Mind you, it's definitely lit up here. So I think it is going to be okay. Well, I'm not going to lie, I am quite relieved about that. You can see it flashing away there on this DeWalt charger. Let me just try that one, because I think I've probably plugged into that one as well. Yeah, and that's working as well. Right, it's not that. Still got the bare minimum connected. I want to check for voltage where it comes up from the board at the bottom. So that's this one here. Because the thing is, even if the touch buttons don't work, we still have to have voltage coming up to make those touch buttons work in the first place. So I'm just set to volts DC here. Probably can't see it with the light. And I'm just going to go across various different ones here. See if we have any voltage. So there was nothing on the white and all the others. Now I'm on the black and there's nothing there. Now I'm on the yellow. There's nothing there. Now I'm on the brown, and there's nothing there. And I'm on the green, and there's nothing there. Now I'm going to unplug this, and let's see if we have anything now straight on this, so we're not connected to the boards anymore. Now I think this is low voltage, but I'm not 100% sure, so I'm just going to go across here. So I'm going to be on the let me see the colours. Let me go on the white and black, see if we have anything. Yes, we do. We've got 5.6 volts. Yet we don't have that when it's on the board here. So there's something on the board that's knocking it out. That's great news. Let me just see if there's anything else. 5.5 volts there. 5.4 volts. So we've got voltage everywhere. So it's not the board at the bottom, I don't think. 5.5 volts. Just going to move to that one. 2.4 volts. So we have voltage all over this thing. Yet when it's plugged into the board, we don't have anything. Right, so that says to me we finally eliminated something, and I think it's safe to work on because it's low voltage. So that means then we've got a problem on either this board here or this board here. So what we're now going to do is let's plug this back in. And let's disconnect this one and see if the fault disappears, because then we know the fault's on this board. So it was on white and black we had voltage. And we've still got no voltage, so it must be something on this board. So now let's disconnect this one here, which is the keypad. Now let's see if we have voltage. We've still got no voltage. Now disconnect this safety lanyard thing and see if we have voltage. Still no voltage. So as soon as we connect this to the board, the voltage gets knocked out. This isn't the fault, but I've spotted something. So we were using a screwdriver to take off, and isopropyl alcohol to take off the glue. I've just noticed now that one of the transistors is lifted up. I'm just going to take a photo of that. I want to see, has the leg broken? You're not going to be able to see it in this camera, in this light. I just want to take a picture of it. I want to see, has the leg broken or has it just lifted up? If it's just lifted up, I can solder it back down. Maybe the solder's just broken. Bear with me. Right, annoyingly, it is the actual transistor that's broken. I mean, there's a slim possibility that this is the actual fault. I just don't think so, because it's too close to the connector. We were using a screwdriver to lever the glue off with the isopropyl alcohol, and there's a lot of force there when you're using that leverage on the screwdriver. But you can see there, isn't it amazing how clear the pictures are? And this phone's from 2019. You can see the transistor's broken. It hasn't just come away from the solder. It's snapped. Now, it's a Y1. I know these are very common. In fact, there's another one underneath it, which is also Y1, I think. I'm hoping I've got them at home. So I'm going to bring this board home now. Hopefully I've got a transistor that I can put in its place. Then bring it back and we can do more fault finding. While I'm at home, I might also just, go across the capacitors, see if there's any shorts or anything. Also, I think I might bring my thermal cam back, because maybe there's something heating up on this board that I don't know about. I know that looks like a break there, but I don't know what that is. I don't know if that's a slip or whether I've got to double check that as well. That might also be a slip through the board. Or it might be something stuck to the board, but I need to double check that. So next time you see this, it will be on the blue mat.
So I'll bring the board back home, and we're now working over the infamous blue mat. It's so much easier doing it here because proper lighting and I can see what I'm doing rather than trying to work from the garden. Also, I need hot air to remove this anyway. So I don't have a Y1 transistor, but when I type in Y1 transistor equivalents, it's saying that is S8050 is the same as a Y1, and the transistor I'm putting up is marked up as J3Y, and there's quite a few websites that say they're the same thing. So I'm just popping one of those in. I do have to make a little bit of repair to one of the traces because it's cracked and the pad lifted a little bit. All I have to do is grind back a little bit and put on a nice blobby bit of solder. So yes, it looks bad, but there's full continuity where it needs to be, because I put big blobs of solder on purpose, even though I do love my blobby joints. While I'm doing this, I'm going to shout out the My Mate Vince Massive. They are the top level Patreons. This month the members are Keemon Services, Kip Hakes on YouTube, Max Rokotansky, Chris Seal, Felipe at MrKeeps.com, DJ VG, Pigsy, Russ Madison, Rickard Bergland, Shamsa Al Sawadi, Stuart Park, Stephen from The Broken Past on YouTube, Lee Benz, AJ Computer Services UK, Chris Bayans, Victor B, Garen Shaw and Lady Leona Drury. So massive thanks to each and every one of you. Now, the reason I've not got any audio on this bit is because annoyingly I forgot to plug in my microphone. But it doesn't matter anyway, because this isn't really part of the video. This is just us fixing a part that we've damaged. This isn't anything to do with the actual repair. Well, I don't think it is anyway. So now we're going to bring it back over to the treadmill and see now, has unplugging everything made a difference now that this board should be working?
Right, back at Brian's now, and I have the circuit board here with the new transistor. So going to do the same again, just connecting up purely the necessary parts, because you never know, it might work now. So we definitely haven't got any voltage there on the meter there. I'm just going to unplug it one more time to make sure that we have here now. Yeah, 5.1 volts. Interestingly though, it did say it should be 12 volts. I wonder, is that the problem? No, but it's being knocked out. So even if it should be, let's say even if it should be 12 volts coming up and it's only giving 5 volts, why is it being knocked out in here? So what I'm going to do is I'm going to plug it in, and I'm now going to disconnect the board going off to the display board. Now let's see if we've got our voltage back. No, we haven't. So now plug that one back. Well, I'll leave that one disconnected. Let's unplug the keyboard thing. We still have no voltage. Now let's unplug this one. We still have no voltage. So there's something on this board, I think, that's knocking it out. Let's go one more time on here. So I think we'll get the thermal cam on and see if anything's heating up, because I don't know if that's coming across in the camera. Let me just put it there. Oh wow, I've got 15 volts now, Brian.
Bloody hell.
No, hold on.
10, 18, 6. Yeah, settling at 15, isn't it?
Well, why was it only 5 then a minute ago? Oh, I've got 15 now. 19. Is it picking up my fingers? Hold on, let's just do this here. .7. So is it somehow picking up my fingers as a bit of a signal and putting through more? Because I was touching those ones there.
I can hold it if you
6 volts. It's growing though.
It is.
8, 13.
That's weird, isn't it?
Unless it is a problem on the bottom board, and it's for some reason not giving the correct voltage.
God.
It's a complicated one, isn't it?
What should it be?
Well, the bottom of this board said 12 volts.
Okay.
Because it's marked up underneath.
Would that be a maximum though?
Well, no, I think it probably would be 12. Oh, I don't know now. I'm now thinking, could it be a problem on the bottom board where the voltage isn't stable? But saying that, why haven't we got voltage there unless it's when there's a load on it?
Should we check the transformer down there, Vince, see what it's throwing out?
But that's going to be high voltage, Brian. That's going to be like the main.
Yeah, but what's it throwing out? I mean, we know it's 240M, but what's coming out of it?
But remember, it was only one wire.
Oh yeah,
It was weird, it was one wire, yeah. I'm not really happy with that. It seems a bit all over the place. Do you know what I mean?
Weird, isn't it? It's very strange.
Okay, I'll tell you what we'll do. No, okay. Let's get the thermal cam on. So this will show up any heat spots on the board, because if, I mean, unsure now because the voltage seems to be all over the place. So what I'm wondering is, if there was any load on that, would it go straight to 0? But if there really is a proper like 5 volts or 6 volts on here, and when we plug it in it goes to 0, you would think it would have a little bit of a heat spot, which it doesn't. I know you can't see it, but there's no heat spot there. Just going to unplug it and then plug it in. Nothing there. Right, okay, there's nothing there, it's not lighting up. I'm just going to quickly look at the board on the other side just to see if there's anything getting abnormally hot. Right, so when I go on here, I can definitely see a heat spot, but it might be completely normal. Obviously I'm not going to put my hand in there because it's live, but if you look in between the transformer and the relays, there is definitely a heat spot there. I went from being certain that it was going to be a short on the board up top to now thinking that this might be giving unstable voltages, and that's why the board up top's not happy. Right, it's only been about 5 minutes later, and yes, we have got voltage here, but when you look at the board here, it clearly says 12 volts and grounds. So it looks like we've got some sort of transmit, receive, 12 volts, ground, and safe. Safe's to do with that lanyard thing, yeah? So on the third one down, it should be positive 12, and the fourth one down should be ground. We haven't got anything on that, even when this isn't connected. So when it's just like that, we haven't got anything. So now I'm wondering if it is a problem on the board down there, and maybe it's not bringing up the 12 volts. Or one other thing, I wonder, does it need to do something on the transmit and receive with the 5 volts in order to see the on and off button? Then the board down there pushes the 12 volts up. I'm not sure, should there be 12 volts on this all the time, or is it only 12 volts after it's been turned on? And that's what makes it hard. But if you look now, we're turned on, and if we go on to the top two that I was going on before, we do have like 5-ish, 6 volts there, yeah? But if I go on to the yellow wire, which should be plus 12, and the brown, we have nothing. There's no voltage at all. But of course, do you only get that voltage after you've pressed the on button? Not sure. Or maybe that could be the problem. It might be the bottom board might not be pushing up 12 volts to here. Well, I'm not going to lie, really struggling here, because it could be that this isn't getting the signal to push up 12 volts, but at the same time the voltage is coming up and disappearing, which would make you think it's a fault on the board up top. But the voltage is not stable. It's like 5 volts, 5.5, 6 volts, 12 volts, 5 volts. It seems all over the place, which now makes me think it's a problem with the bottom board. So I've undone the couple of screws at the back for the what I think is the bridge rectifier and the switching transistors, and you can see here there's all like thermal compound and stuff. Look at the size of this cap here. This has been unplugged for maybe 7 or 8 minutes now, and there's still voltage in it. So if I was to angle that here, let's see what's in it right now. So it's still got 92 volts right now, but it is going down. It was 100 and something volts before. You can see it dropping. Now I could short between the cap and make a little bang and make it go down quicker, but I'm just going to wait, because you can see in a few minutes there that's going to be gone. And I think what I'm going to do is, so clearly we have got some sort of voltage, so I think the primary side of the circuit is working. I mean, I'm worried it might be something to do with this chip here. We need to somehow maybe look back from here and see where it goes to, see if I can see anything obvious. I might have to take it to the mat and look much closer at it, because it's a bit hard to see, see here, but I'll do my best. I could be completely wrong, but I'm thinking that we should have more stable voltage going up, and I think maybe that's why it's getting knocked out, because as soon as you plug it on the board there's going to be a little bit of load. I haven't got resistors with me. If I was to go across with resistors, I might also find that the 5 or 6 volts goes to 0 as well. So although it does look like a problem on the top board, I'm just really unsure. And this is the beauty of having more than one treadmill, because a professional would just swap this board out in a few seconds and be like, no, that board's okay, let's move up to the other board, swap that out. Oh look, this one doesn't work in this working machine, so that this board's faulty. But right now I have zero idea whether it's this board or the other board, but I'm thinking more this one. Right, we no longer have volts on our capacitor here, so it's safe to work on. And I've just been trying to trace back from where the power goes up the arm of the treadmill to the the display up top, and it's slightly different on this one. The wires are ever so slightly crossed here, so we want to be on yellow and brown is at the edge and yellow's in the middle, so that's different than the one up top. So obviously the wires are crossed as they go up. So we want the ground to be on this side here, and we want 12 volts to be on this middle one. Now the middle one goes up to the capacitor, this little 25 volt capacitor just here. So if I was to go here and here on continuity, you can hear that the middle one goes to here, and the ground, which is the brown wire, goes to the negative of the capacitor, which is correct, yes? But listen to this. We have a short on that capacitor, or on that rail, and if you look at my meter, it is actually a short. So let me just go to here and touch my wires leads together, the probes. You will see that right now it's 1.3 ohms. Yeah, so that's what my meter is when they're touching together. And if I went across that capacitor, the electrolytic one, you see it's 1.55. So I think that's knocking out our power. So we need to find out what's on that rail. And it does seem to go down here on capacitors and stuff. It's just very hard to do here in the garden because I'm trying to bend over with my eye loop. I'm going to have a little look around the place and see if I can work out what's on that rail. But I think I probably will have to take this back to the mat again. But I feel now as if we've made progress, because why do we have a short on that capacitor? We shouldn't have a short on that capacitor. Right, trying to look through the circuit, it's very hard to do here, but it's definitely got an SMD cap here, a little ceramic cap, and if you have a listen on just continuity, on the bottom SMD one, there's no short on that cap, but then we have a resistor, and then on the top SMD one, we have a full short again. But what's also interesting is we've got a diode just here. As far as I can see, that diode shorted, because if I was to go to diode test, and if I was to put my leads together, you will see that we have that read in there. And now, if I go across the diode, you will see we have that read in there, so that's a short. And go the other way, black lead up, black probe up top, that's also short. So maybe the cap isn't shorted, the rail might be shorted from the diode. Or maybe the diode's given the wrong reading because the SMD cap is shorted. I think I need to go back to the mat because I think I'm going to need hot air to take these off to prove where their short's coming from. But unless this thing has more than one fault, which I don't think it does, I'm now thinking that this board here isn't putting the correct 12 volts up because it's shorting to ground. So I feel like we've actually made good progress now. So let me get this board back to the mat and see if I can find out where the shorted component's coming from. Now, hopefully, it's a little bit clearer now. So meter on continuity. And the third pin here should be 12 volts and this should be ground. And if we go across it, you can see that we have a short, which is not correct. And if you go to this top capacitor here, we have a short. Now, I don't know, do you know what that actually might be? Looking at it now, I wonder if that's a tantalum capacitor rather than a diode. And if it's on the same rail, it looks like that's shorted as well. So let's zoom right away in. It's very hard to see on this board what's what, as in the traces, because it's green on green. And it's covered over by most of the stuff. But I'm wondering if we should start on the little SMD capacitor. That one there, because that one does have a short, but this one doesn't. So I think it goes up to here, back down. So I think this one goes to here, but I can't be sure because obviously the ground's shorted as well. Are any of the others? No, I'm hopeful that this is the fault. And then I think it goes up from this one up to here. I think we're going to start here. So let's get some heat on that, take it off, and then hopefully we'll start breaking down the circuit. If that's not the fault, it might narrow down whether it's on the left or the right. So 450 degrees Celsius, and we are 100 out of a possible 200. I'm not going to try my best not to burn that there. There we go. Now I managed to knock off that transistor, which is a bit annoying. I'm just going to heat up the pad. Do you know what? I better add a bit of solder to those pads there. Right, so you can see I've put a little dollop on each of them. And let's get the hot air back on and get the transistor back in place. There we go. Right, I let the Harrier jump jet over here calm down a little bit, and then we'll measure to see if we still have a short. Oh, look in here. So this must be capacitor 55. This must be capacitor 15. Resistor. And this must be D for diode. Diode 8 and diode 15. So it looks like it possibly is a... well, maybe not an SSD9. I'm not sure. Don't know. Anyway, it's calmed down. Let's go to continuity. Do we still have a short here? Come on. We do. Uh-oh. We do. Oh no. So my capacitor here isn't going to be short. No. So it's not you. Oh no, I hope this isn't going to be some weird one. Right, well, I mean, it's not going to be that. Let's just see if that diode, what's that doing? That's not shorted. You are. Okay, let's take out this massive, what I'll call a diode, but I don't know if it is or not. Now I'm very close to this cap, so it may go pop. Oh, it is a diode, look underneath. Now, let's see what we have. No way! No way, it's gone. It's gone! Wow! So this goes to here, and this must be ground, which it is. We've got a shorted diode. Let's zoom out. That's pretty bad actually, because I don't think I'm going to have anything like that. But it has got a marking on it, so I might be able to read up on what it is. So let's turn it around to make it easier. Boom, boom. So you can hear that it's going in two directions. Wow, a shorted diode. I wonder would that have taken... I'm not sure if I've had like shorted diodes before. Not very common for me. I wonder has something else gone to take out the diode, because I think that's what normally happens, is when something catastrophic happens and then it takes out the diode. I don't know if I've seen a diode just fail. So I've replaced many diodes, but along with other stuff. Right, okay, I'm going to pop that little capacitor back in, because that's fine. I'm going to do that with the soldering iron. And then we've got to look into what diode that is. So I'll pop the little cap in because we know that's okay, and I need to find out if I have any of these diodes. The markings on it say SK510. Now looking online, they're not super rare, but I can't find one. But I've typed in SK510 equivalent, and then it's come up with a whole list of diodes that are similar. They're 100 volt 5 amp diodes, and I do have one which is supposed to be an equivalent. The problem is it's half the size of the diode that I've taken out. Right, it's a Schottky diode, 100 volt 5 amp, and direct equivalents include the SS510, SB5100 and SDT blah 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 blah. So it looks like I just need a 5 amp 100 volt one. And if you're wondering what a Schottky diode is, it will have a lower voltage drop than normal diodes. So you know, often when you do diode tests you might have like 0.6 volts. Well, you can see here 0.7 volts would be normal. Well, Schottky one would be 0.15 volts to 0.45 volts, and also ultra fast switching because it lacks a reverse recovery time because it does not store charge, allowing it to switch states almost instantaneously. So it's high efficiency, less energy is wasted as heat, which extends battery life in portable electronics, and I suppose makes things more efficient because you're not losing energy through heat if it's not needed. Now, I bought this kit a long time ago from China, It might have been from eBay in the UK, but it would have originated from China. And it's a little diode kit here. And you know, I had a look and it said equivalents. Well, SS510 was an equivalent. I couldn't believe it was here, because when I'm looking at these, they're so much smaller. I mean, look at the size of the one that came out, which I've now lost. Here. And look at the size of these. I mean, it would almost take up 2 of them. But I think these might be a little bit thicker. But it does say it's an equivalent. So I've got them here, SS510. And if you have a look here, you know, that's a wider one there. But then that's a normal one there, SS510. So maybe they can handle what they're supposed to handle. It says it's a surface mount Schottky, which is the same barrier rectifier diode with a maximum repetitive peak reverse voltage of 100 volts and average forward rectifier current of 5 amps. And on the last page, it said that they were identical. So SK510 diode equivalent, SS510 identical 5 amp, 100 amp ratings, often available in the same surface mount footprint. Well, it's not the same. And what it is, the footprint is, no, it's less. This is a lot smaller. I might buy up some of those SK510s, but if these are the same, it's amazing that these can handle the same current when they're that much smaller. But anyway, watch this. If I go to diode test, hopefully this will be behaving like a diode. But you can see it's a lot lower, 0.29 rather than 0.6. And if I go this way, nothing. Well, this is a full short both ways. Yeah. If I was to go to continuity, you will hear short, short, nothing, nothing. So let's pop this in. Is it even going to fit? Yeah, I'll make that fit. It just looks so tiny. It just looks so small compared to the other one. I'm going to pop it in. Let's see if the treadmill comes alive, and then I'll order some of these up from AliExpress. And then what I can do is when they arrive, I can ask Brian if he wants me to swap it over or just keep them. And then if this one fails prematurely, then no bother. I'll put in the bigger package one here. So I pop in this much smaller diode and I make the solder joints really big to make sure they fully engulf either side of the diode so we have a good connection. And then we're going to pick up this video the next day. Back at Brian's, it's another hot scorching day. Let's get this board in the treadmill and see if it comes alive.
It is the next day, Mr. Keeps.
Right, it's the next day, we are back. So I'm going to be popping this in, I'm going to be putting the heat sinks back on with the nuts and bolts, and then we'll see if we have 12 volts coming up here. My thinking is that as soon as we turn it on, I'm wondering if it's just going to go bang again, because I just think it's a bit weird that a diode's just failed, but we'll see. Right, it's back in here, but we've only put the minimum in, as in mains going in and just the cable coming up, because we want to see now, is there going to be 12 volts when we turn it on up at this point up here. So I purely want to see if we have 12 volts. So we're on the negative and also the plus 12 volts, so the brown and the yellow. 0 volts at the moment. I'm going to turn it on here. We'll see what's happening. Excellent, we've got a beep and we have 10.9 volts. Right, I'm going to turn it off because nothing else is connected, but that has behaved differently. Fantastic. That's behaved differently than anything previously. And we had a little beep from the piezo buzzer. So let's get it actually back together now and then see if it comes alive. Right, and I've put this back together now, so all the motors and stuff are connected and I've cable tied that up again. So now I'm going to put the cover on for safety. Right, testing time. The screws are not in, but the cover's on, and this is back together here. Hopefully we'll be able to see something in the sun. Right, let's plug this side in first. Now let's plug this in.
Turn it on here.
1 second, Brian. Do you want to have the... Go on, you go for it.
You want me to turn it on?
Yeah, go for it. That's a good sign. Shall I stand on it? Reebok! Yes, we have a screen. Reebok, fantastic. I don't even know, can you see that in the sun? I don't think you can see. Look, we have like lights going round. So that must be warming up. Yeah, try to cover that up, Brian. Oh, there you go. I think they can see. A bit more over here, if you don't mind. That's it. That's it. That's the one. Do you reckon it's just kind of warming up because it hasn't been done in ages, or do you reckon it's waiting for us to hit start? Oh, here we go.
Oh,
no
wow.
way, it's come alive. Right, I'll tell you what we'll do, because it's impossible to see. I think we're going to push this machine. Let me put all the screws in, because it's definitely doing something. Let's put all the screws in, I think, and then let's get it back into the shade, because nothing's really coming across in the camera. Right, it is fully back together, and it's in its home here. Hopefully you'll be able to see the screen now. So turn it on. Now you can see it says Reebok. I better attach this to me just in case I go flying. I'm only going to do walking pace anyway. Oh look, so it is slightly coloured as it does that. And last time we pulled this off to see what it says, and it did say something about reattached. It beeped and it said reattach to safety lanyard, so it looks like that is working. Right, okay, so we're here. In fact, I'll show you it now. Take that off, and it says insert safety key. Right, I'm going to do quick start. Let me just see the buttons here. So volume, that must be speed, and this is the incline. So quick start. 5. I hope it doesn't suddenly go crazy. 1, go. Device error. That's not good.
Try pushing the green button. I'm a bit worried.
Oh, to start. Hold on.
Because James told me just told me to push start button.
5, that's it. I think that's going to do the same thing. Oh. Device error. Oh no. E2 device error. Well, maybe this might be what blew the diode in the first place. So I'm going to Google what E2 device error is. Now, E2 is apparently a motor problem.
Obviously, it goes without saying, we're unplugged from the mains electricity.
So I thought, okay, well, let's take out the board and then have a look at what's before the diode. Maybe the relay's not working, which took out the diode originally. And as I was undoing things, I touched this here, and this is for the angle up and down, because this is for the actual treadmill, because you can see when I move this that the treadmill's moving. This is for the angle up and down. This here is red hot. Like, even now, and it's been turned off for a few minutes, this here, I couldn't keep my finger on that. It's much hotter than a radiator. So I'm wondering if we were just to disconnect this from it, because maybe this is putting some abnormal short on it, would it actually work for this? Or does the Reebok machine have to see everything before it starts working? But we're going to try disconnecting everything to do with this from the board and then seeing what happens. Oh no, Vince made a boo-boo. I hope, no, I can't believe that, because I took pictures. I hope I haven't ruined it completely now. So you know this is getting red hot. Well, I wanted to disconnect the wires from this, and then I unplugged these two, and I'm like, hold on, they're not with the white one. And these two here are for the DC motor here. And look what I've done. I've plugged in, let's call it the rake, the angle motor. I've plugged into the DC connections here. So I'm not sure now, have I done irreparable damage to that or not? So that's why I think it's not working, is because I've stupidly connected these two. Should have been here for this. So this one here connects on these 3 terminals here, and the DC motor connects on here where it says M plus and M minus. But look what I've done. I've put the M plus and M minus into these. It goes round here into this here. So I'm going to let that cool down for a bit. I'm just wondering now, so we've put DC voltage into AC. I'm not sure now, have I messed up the windings in here? Ah, what a disaster. Right, so we've just taken the lid off here just to see, and you can see all the windings here. I mean, they're not a complete melted mess together, but I'm not sure if some of them are a bit more discoloured here, for example, than the others. So even now, it's only just about touchable. And I've been blowing this little gadget that Brian's got on it to try to, well, I won't do it now because that thing's on it here, but when the cover was on it, to try to cool it down. So what essentially I did there is I made it into a heater, which is annoying. So all of these, so what could have happened now is that these are all enamelled, meaning that there's going to be, let's pretend there's 50 meters of enamelled wire here, and when you go across it with your multimeter, it might be something like 50 ohms, for example. But now, if they've melted together, it might be just the same as a lump of copper. So it might be just like, you know, like 10 centimeters of really thick copper rather than 50 centimeters of copper, which is as thin as your hair. So yeah, I can't believe I did that, because I think it would have been working. What we're wondering is, would it be worth to begin with disconnecting the incline motor and also the incline, is it a connect? Yeah, disconnector here, just to see, does the treadmill come alive without this? Because at least then it's going to be a working treadmill, but it would just be on the one level. You could probably turn this to actually get it to the level you want and then just leave it at that. At least it would still be a working machine until a new one of these could be bought, because there's no way I'd be able to rewind that. So we might do that, or it might throw an error code once it realizes it can't see this. So I've disconnected the sensor for this, and I've also disconnected the 3 wires for this as well. Let's see now if it is going to come up with an error code because that's disconnected, or would it actually work as a treadmill? See, my worry is when we connect up the angle 1 again, if it is now just a melted mess of copper, it might now blow the relays or the chip feeding that part there. Right, okay, so we're on here. Shall we press start and see what it does? Is it going to come up with an error?
Get ready just in case
Yeah.
it doesn't.
Go. Oh my god, it's working. Wow, it's working. Right, okay, I'm on a bit of a slope here.
Shall I push stop?
Yeah, no, that's okay, I can do that. Right, so I'm just going to go up a little bit on the speed. Yeah, it's going more now. Okay, so look, we did fix it, but I did a My Mate Vince special on it. But at least I show my mistakes. I'm going to have a chat with Brian now and see whether or not we should try to connect up the rake angle, or whether or not that would be a stupid idea, because you see it is working as a treadmill, and I'm pretty sure the rake could be set to maybe like 3 or 4 degrees just by turning that motor, and it would stay in that position there. But we did fix it. Right, Brian's being brave, which is what I would do as well. So it's still warm, but it's not radiator hot now. I've connected it back up. Let's see what it's going to do.
The red lights come on straight away there.
Yeah, yeah. So we'll let it boot up, and then I'll get on it, and we'll actually see, will it still do the error, or will it work? And if it works, will it do the incline? Oh look, you can do the incline here on this one, and this one here is for speed.
Okay.
And this one must be heart rate, I reckon. We're just saying down here on the circuit board there's like red lights and stuff, and when that E2 error came up, that red light disappeared. Can't believe I've connected it up incorrectly. Here we go, we're ready. Let's go to start. What's it going to do? Okay, excellent, we're off. We're off, let's speed it up a little bit. Put my lanyard on. Right, okay, so I'm at a slow walking pace now. Should I try the incline, or do you reckon we're at a bit of a... See, this isn't even flat. Let's try the incline. Yes, it works, I heard it. I'm going to go again. In fact, does it say incline on here? Incline 1%. Incline 2%. So the incline's working. I'm going to go up to 3%. 3%. Right, now let me see if it will go down. No way. 2%. So maybe that little AC motor is more hardy than I think. I'm calling it an AC motor. I don't actually know if it is or not, but it was heating up a lot. Fantastic. So the incline appears to be working. I think I'm turning it off. Ah, so every time you stop it, the incline goes back to 0, and it's got a workout summary there. Let's put it all back together and let's get it back in its home. And I suppose if it fails again, we now know that, well, it might not fail again. Maybe that incline motor, because the incline motor is not going to get as much use as the treadmill motor, so might well be fine. Right, we didn't have a glue gun here. I thought Brian might have one, but he didn't. So I just reused the old glue with a soldering iron to melt the old glue on these connectors again. Well, here we have it back in its home here. So I was sure it was going to be corrosion based, but it's not. Everything in here is really dry. Also in the UK at the moment, it's a heat wave. It hasn't rained for quite some time, but it is up and running, which is just fantastic. So if I go to start here, you can see it's counting down. And away we go. And I'm just going to put the incline, let's put the speed up so it's actually comfortable to walk. Oh, speed 1.1. It's because I don't know this machine. Right, okay, so that's 1.4 there. That's a nice comfortable 1.5, nice comfortable speed to walk. And let's give ourselves a little bit of a hill. Let's go up 5% on the incline. And there we go, it's moving its way up. So all of this failed. Yes, I did a My Mate Vince on it and messed up and put the wires back incorrectly, which should have been one of the easier parts of the job. It all failed because of that tiny diode. What is that about? I would have thought that something caused that diode to fail, but it looks like the diode just failed. I love that there. That there is a perfect video, a perfect fix, because this whole machine here didn't go into landfill because of that one little thing here. So Brian's son's going to be well happy with that now. I'm already getting tired because of the incline. I'm going to put the incline down. Let's go back to 0. Well, I thoroughly enjoyed that there. Some fixes are more enjoyable than others, but for me, that was brilliant. And it's a product that's in use. They were already looking for other treadmills, so the fact that hopefully now this will keep on working is fantastic. I've ordered up 10 of these for, I think it was about £3, so you're looking at about 30p a diode. Most of that is postage cost. So this whole machine here was fixed for between 20 and 30p, or you know, let's say £3, because you would have had to buy 10 of them. So I think that's fantastic. So if there's a problem again, I'll come back and I'll put in the correct size diode, and hopefully this treadmill will go on to give another few years of service, which will be fantastic. If you enjoyed this video, give it a massive thumbs up, and I will see you all again very, very soon. Let me end on a bit of a sprint. I'm running. There we go. Thanks for watching, everyone. I'll see you soon.
Bubblegum fights on the 3rd floor. Comedy specials at 8. Fishing rod and a quiet fear that what I caught wouldn't be big enough. You would lie and say I did great. And all of these moments, they add up to something that feels so big. And all that I'm left with's a dry throat. I lose my head when you call me up and ask if I'm